Today we will discuss surface energy reduction. In the past two lectures, we have discussed about what is surface energy, from where it came into picture with reference to nanoparticles, and the details about surface energy, the mathematical background about this energy. Now we want to involve more into the subject, the reduction of surface energy. As a matter of fact, we all know that no system wants to live in high energy system, high energies. So same with the surface. And whenever there is a high energy on the surface, this high energy reflects in some other form, or the surface wants to reduce this energy anyhow. So this is one of the most important topic of nanoparticles. You can say this is also a challenge. You can also say this is also an opportunity to develop new kinds of nanoparticles, because it may also help in shape arrangements, may also help in addition of other materials and so on. In this unit, we are talking about surface energy. Actually, it is a physical chemistry of solid surface. We have developed the concept of surface energy, and in these lectures we will develop the ways to reduce surface energy. First, we will introduce here what is surface energy and what is its significance. Then we will study the ways of reduce surface energy. There are several ways, and we will discuss one by one these here. We will also discuss the idea of agglomeration, and finally summary and conclusion. With this lecture, we will be able to understand the complete picture about ways to reduction in surface energy, its significance, and its effect on size and shape of the nanostructures. We have discussed this issue, the what is surface energy, in detail in the previous lecture. Just to begin with, the surface energy basically an excess energy on the surface of material. The atoms that are inside the material have force in all the directions, but the atoms which are on the surface have force only inside the surface. There is no force outside the surface, and that is the reason they behave as having excess energy. Basically, this energy is work required to build up an area of a particular surface. We can also relate it with a bulk sample. The surface energy is to the work required to cut a bulk sample into two different surfaces. This is surface energy which is required to break the system. In the figure we have shown various sizes of gold and silver nanoparticles. The size, it depends on how the energy is reduced here, how the surface energy is reduced in the case of solid gas, golds and silver. Let us see some interesting results here. Here we have gaseous state, liquid state, and then solid state. In the case of gas, there is no interaction between atoms, and that is the reason the atoms are away from each other, moving away from each other. But these atoms lose their energy and form a liquid or solid. As a matter of fact, they lower the energy, forming a solid or liquid. This is also shown here. The energy of liquid is less than energy of gas. Now, if you further reduce the energy, they become solids. However, the solids have partially bounded surface atom that we have discussed in detail in the last lectures. Now, these surface atoms, as shown here, are responsible for excess energy. Now we use two different terms which are related to each other, that is surface tension and surface energy. The surface energy is the energy which costs or which is there to put an atom on the surface as compared to bulk. If you want to put an atom on the surface, there will be some energy because the surface atom doesn't have equilibrium forces. They have the force only towards inside the surface, not outside. There is one more term we use that is called surface tension. The surface want to minimize the area, want to shrink, and want to live in lower energy, that is called surface tension. So we use these two terms, surface energy and surface tension. You can see here sigma. Sigma is surface tension, force per unit length. Always we use the term N Newton per meter. However, the second term we are using here is surface energy. The energy is always used in the form of energy per unit area. And this surface energy, which is equal to J upon m square, or in place of joule, you can use the force into meter. So finally, the unit is Newton per meter. You can see here both the term, whether it is a surface tension or energy surface energy, both have same units. We can say that the dimensionally sigma and gamma both are identical. Physically, they are different type of quantities. Gamma is scalar while sigma is a vector quantity. That is the difference between these two. Otherwise, both give the same results. The surface energy, particularly for nanoparticles, is one of the most important quantity in understanding the thermodynamics of particles. Therefore, it is surprising that there is still great uncertainty about its value. The uncertainty increases if one question its dependence on particle size. Yes, particle size. The different approaches such as classical thermodynamics calculations and molecular dynamics calculations and ab initio calculations exist to predict the quantity. Generally considered based on classical thermodynamics lead to prediction of decreasing value of surface energy with decreasing particle size. We know the system doesn't want to live in high surface energy. So the system will find some ways to reduce this energy. Now we should control this reduction in the surface energy. For a given substrate, suppose the surface area is fixed, and in that surface area the surface energy is there, and we are also talking about solids only, we are not talking about liquids and gases. Liquids and gases have, as we seen in the last slide, have enough flexibility to reduce the energy, but we are talking about surface of solids. In this surface solid of solids, the surface atom or ions shifts inwardly, which occur more readily in liquid phase than in solid surface due to rigid structure in solids. In this surface relaxation, the atom wants to move inside. This is not easy in solid surfaces, but this is possible in liquid phases. But if we are having this tendency may give you some different shape and size of the surface. We will discuss it in the letters in other slides. Now the second is surface restructuring. As we have discussed in the previous classes, the surface have some dangling bonds, and these dangling bonds are in a strained position, strained state. The surface restructuring may help in combining new chemical bonds, combining these dangling bonds, and this combination may help you to give you a surface restructuring. There is another way that is called surface absorption. The absorption through chemical or physical absorption. I think you are aware of these words, chemical or physical absorption. We have two words, absorption and adsorption. absorption, the absorption is to a bigger extent. But here we are talking about adsorption. Adsorption means adsorption means the chemical or physical material may be just on the surface, and these absorption of terminal chemical species onto the surface by forming chemical bonds or weak attraction forces. We know this that weak forces like van der Waals forces or electrostatic forces can be used here. This method is again a very good opportunity to develop nanoparticles for sensing applications. As we know, the sensing application works on the principle of adsorption in a small quantity, and that is possible here. The bonds which are present on the surface may be linked with some of the species and can detect that. The last one method of reduction is composition segregation or impurity enrichment. Surface we have, and surface may have some reactions like diffusion, solid state diffusion. And using this diffusion process or enrichment of impurities, the material may be segregated each other and will give you bigger material, bigger molecules, bigger size of the nanoparticles. So these are the four ways of reduction of surface energy. And now we will discuss these ways one by one in the coming slides. In the first place, we will discuss surface relaxation. The relaxation that occurs in the system due to some rearrangement process towards inside the surface. To feel the first classification, surface relaxation, let us take surface atoms on an atomic flat 100 plane. If you take a simple cubic structure and 100 plane of the simple cubic, then each atom will have coordination number 6. We know that the coordination number means the number of nearest neighbors, and the value is 6 means in simple cubic each atom have coordination number 6. 4 surrounded surface atoms and 1 top and 1 bottom. In this relaxation, surface relaxation, we can say that the material is having some layers, and each bond acting as an attractive force. There are many bonds exist, and they also have some attractive force in solids. These attractions are towards the surface atom under the influence of net force pointing inwardly in the perpendicular to the surface. Now each force, the distance between the surface layer and the subsurface atomic layer would be smaller. You can see here the top surface and the second layer, the distance will be less. See here. Here the first is this top surface and the second one is this. Now the difference, the distance here shifting is observed here. And the shifting plays very important role here. However, the structure of the surface atomic layer remains unchanged. It is seen here. But in the case of relaxation, it will shift it. The bond length is get reduced for the top layer. In addition to this, the distance between atomic layers under the surface would also be reduced. Such surface relaxation have been well established in the system. Relaxation in the top surface is one of the way to reduce the energy. Of course, the surface may not be changed, but some deformation or the size change it takes place here. Here we have discussed the shift in perpendicularly, but the surface atom may also be shifted laterally related to subsurface atomic layer. In lateral shifting, the atom gets displaced on the top surface than in the second layer. So this is another aspect can also be understood. However, for bulk materials, such a reduction in lattice dimensions is too small to exhibit any appreciable influence on overall crystal lattice constant, and therefore it can be ignored for bulk materials. For nanomaterials, it has significance. As we have discussed in the previous slides, due to these relaxations, the surface energy gets reduced and there is an attraction forces. Due to this, the bond length will be decreased. However, such surface relaxation become more prolonged in less rigid crystals. In rigid crystals, it can be ignored, but the crystals are less rigid, then can result in noticeable reduction of bond length in nanoparticles. So there is another aspect, the aspect of rigidness. If the materials are rigid, it can be ignored, but for non-rigid materials, it has to be taken into account. We can conclude that the reduction in surface energy is a natural phenomena, or we can do this by some way. We can develop some applications of this. in the development of some sensing applications. Reduction of surface energy may have many mechanisms, but surface relaxation is one of them that we have discussed here. This is more. The rest of the mechanisms we will discuss in the next lecture. The reduction of surface energy has its significance to develop many sensing applications. I think we should talk about this and learn. So, thank you all for this. Try to learn this, the behavior of nanoparticles, why this is so important, and how the energy can be reduced. We will discuss some other ways, another mechanism in the next slide. Thank you.